when you run iRuby, it will give you a main object. This is the line number. That's the nesting level. So at first you have a nesting level of 0. You can just type any Ruby command. You don't need to terminate anything with a semicolon. So this is print. Now, string literals, of course, could be quoted in double quotes or single quotes, just like in Perl, and of course there's a slight difference. With double quotes, the escape character is interpreted. So this gives you a new line. Nil is basically the value of print. If you quote in single quotes, then the escape character is not interpreted, and you get the whole thing out. Okay. To get out of the IRB, you just do exit or quit. Ruby is pure object-oriented. So all values in Ruby are objects. Okay. We have some of the standard building classes like string, fixed num, float, array, hash, range. Also, Ruby has a class called big num. There's no limit to the size of the big num. Big num is an integer. The size is basically limited by what your computer can do. Okay. This gives you some examples. Now, this is something that you don't see in other languages. Quote 2 is a string. It's a constant. But since any value is an object, so this is an object. It's a string object. To find out the class of an object, you just use the method class. So the string.class will give you the class of that object. And the class is called string. Here, 2 is a fixed point number. 2.class is a fixed number. Floating point numbers, you need to have a digit after that, otherwise it will be very confusing. So 2.0 is a floating point number. Dot class gives you the class called float. Even nil is an object. So the class of nil is the nil class. Same thing with true and false. True is the class of true is called true class. Arrays also are classes. So this is a literal array. Again, it's an object, and the class is array. You also, of course, have hashes. This is a hash, and the class is hash. This is a range. The class is range. Now, there are two ways to represent ranges. You can either use 2 dots or 3 dots. The difference is that with 2 dots, the maximum value is inclusive. With 3 dots, the maximum value is excluded. Strings, you have the usual string methods like length, reverse, splice, split. So A is a string, A, B, C. You can find out the length. Just say A.length. Notice that for methods, you don't need parentheses, unlike in some other languages like Java. So this is an object.method. Length is 3. There's a reverse method that reverses string. So B actually takes the value of CBA. However, A is not changed. So if you print A or you just say A, you get ABC. If you want to change the string, you have the bang here. So any method name followed by the bang symbol is destructive. So if you say A.reverse, you assign it to B. Of course, B is still CBA. But A itself is now modified. You have methods like capitalize. It will just capitalize the first letter. Upcase will capitalize all letters. Some more examples here. We now have a string called ABCD. This looks like an array element, but actually it gives you the first, well, element 0 of the string. So you can sort of treat this string kind of like an array. What this gives you is actually the ASCII code of A. So the ASCII code of A in decimal is 97. So this is the first character. You can look at a substring. You specify a range. So from 2 to 4, so there's 0, 1, 2, 3, 4, so you get CDE. Or you can use the slice function. Again, the parentheses are not needed. All you need to do is have a space. So this says element 1, 2, 3. So this is B, C, D, and you get this. This has a bang in it, so this is destructive. If you take the slice, now this is a range and this is a substring. This is actually a string. So you get this, but now you slice out the substring CD. So A has now only ABE. Okay? Because again, this is destructive. You can split a string into an array. You just have to specify the splitting string. So you have A1, B1, C1, and we split it on 1. Then you get 1, 2, 3 elements in an array. By the way, if you have any questions, you can just stop me anytime. Regular expressions are very useful. Again, for those Perl programmers, you will see that a lot in your programs. So regular expressions will create patterns that match sets of strings. You can use it in pattern matching. You can use the reg.exp.nil to create a new regular expression, or you can just use the regular expression literal. There are special characters that you specify in the regular expression. Those have special meanings. To create a regular expression literal, you use the // This is the simplest way of doing it. So A is a variable. This pattern matches any string that starts with the letter A, followed by the letter B. The plus sign means one or more. So this will match any string that has a single A followed by one or more B's. Okay? What you get, of course, the result of the expression, of course, is the regular expression. Or you can use this reg.exp.nil to create a regular expression. So what's in the quotes? Now this is actually a string. We'll turn this into a regular expression. The square brackets denotes the set of individual characters. So this will match any individual characters in the set. That basically is all the lowercase letters from A to Z. Now we create a more complex pattern. Okay? Remember that we have some special characters. The caret and the dollar sign are anchor characters, meaning that the starting point has to be the beginning of the string. This will have to be the end of the string. So the entire string will have to match what's in between. Okay? Again, we have a set of letters from A to Z. The parenthesis is used in grouping. The pipe symbol is the OR. So this is also a set of single characters, and this is also a set of single characters. So what this pattern will match would be a single letter followed by a single letter or a single digit. The curly bracket specifies the minimum and the maximum. So minimum is 3, minimum is 1, and maximum is 3. So this group will have at least one character and a maximum of 3. So from here to here, that's the regular expression. The I following that also has special meaning. I basically means ignore the case. So what this pattern will match is you could start the string with any letter, uppercase or lowercase, it doesn't matter. followed by one or more letters or digits. But the maximum, of course, is 3. The next pattern, we have a wildcard character. So we start with the letter A, followed by basically a dot will match any character. The asterisk, of course, is 0 or more. So you have A followed by any number of characters followed by 6. Okay. So now we do some, this is the pattern matching operator. A is the pattern. We're trying to match the string to see if it matches or not. Okay. Remember that this is one A followed by another B. Now, of course, this A isn't followed by a B. So the matching will keep on moving down until this position. So you will match A with 2 B's. The position is given as the result of the match. So position 2. So this is 0, 1, and 2. For the pattern C, again, we want that the entire string has to match. We start with a single character, single letter. This is a capital letter, but again, it doesn't matter what the case is. Followed by 1, 2, 3 letters or digits. The matching position is 0. Okay? So this is the matching position. Now we have another string here, 1A, 2B, 3C, 4D. We can use the match function. Here's the pattern that matches a single A followed by any number of characters followed by 6. What this will give you is the string that match. So we have A followed by 1, 2, 3 characters followed by 6. And that's the matching substring. So it's very easy to extract substrings using regular expressions from a string. And that makes it a little bit harder to do if you're trying to do it in Java or C. For simple while, we have getAs, which will get a string. They've already seen the print. Printf is, of course, similar to C. It's the formatted print. PutAs is putting out the string. So A gets a string from the input. We type 1, 2, 3. Return. The valve A, of course, also gets the new line character. The chomp method is used to chop out new line characters at the end. Okay. This, of course, if you use the bang, is destructive. So we chop off this character, and you end up with those. If you print A, we'll get this. Printf, again, is formatted, so use the same format as we see. So we're printing in hex. AB is a string. 0 is the first character. So the first character is A, but this will return the ASCII value. And we want to print out the ASCII value of the character A. And of course, in hex, little a is 61. The PutAs, of course, will output a single string. Now, this is a string, but if you want to do some operation, this actually is a number. Doesn't matter, you can always convert the number to a string using the 2s method. So you end up with 2 plus 4 equals 6. An easier way is to actually embed an expression inside a string. The way to do that is to use the curly brackets and the pound sign. Okay? So this will do exactly what the other PutAs does. So it puts out the string, and when it sees this construct, the expression is evaluated, and the value is returned. If statements, there's no mystery here. We have the if, the and. We don't use curly brackets unlike in C or Java. This is a block. you end up with the AND statement. So you have a condition, and then you have statements. You also have if, then, else, and if, then, else. So this is pretty typical. The case statement, you use the word case. You're testing the value. You use keywords when and else. When something's matched, then you can do whatever you want. You don't need to use the break statement to break out the case. Only one of the when will be executed. Of course, the else is kind of like the otherwise. If none of the when matches, you execute this. Again, it ends with the AND statement. The next construct we want to use loops. You have a while loop. So you have a while do. Again, the do is matched with the AND. Actually, the do is optional, but this makes it look nicer. So while true, we get a string from the input. This is an if modifier, again, for Perl programmers, you have seen this. So you would break if the condition is true. So if we just type a carriage return, then we get out. Otherwise, we take A, convert it to an int, add 1, and print out. Now, if A doesn't look like an integer, then when you convert it to an integer, you get a 0. So if you type the letter X, for instance, the string X converted to I is a 0. So you don't get an error. So this do and you have a block. Now we have a for loop. So with the for loop, you have a counter that counts over the range. So for I in this range, you do. Okay, so again, you have a do and. In Ruby, if you just want to do something a number of times, it's a lot easier to just say a number. So if you want to do something 3 times, like over here, you just say 3. 3 is an object. Times is a method that allows you to generate a sequence of values. It goes from 0, 1, 2. Okay? So we'll do something 3 times. Now this is also a do block. A do block can take on parameters. So I is a parameter. You use the type symbol. The 3 times method will generate individual values, and that value will be received in I. So you're using those values inside the block. Since the values will be 0, 1, 2, what we'll be printing out will be 1, 2, 3. Okay. I plus 1. So you get 1, 2, 3. Since we don't have a new line character, you don't see a new line. The value of the expression is still 3, because 3 is what we got here. Okay. So this is something that you don't see in another language. But because it's purely object-oriented, so anything is an object. Arrays, array elements could be of mixed type, unlike the statically typed languages like Java. You can't do that. But here, this is dynamically typed. You can use the array.new method to create new arrays. The array is dynamic, so you can grow and shrink an array arbitrarily. You can use this operator to append a value to the end of the array. You can delete elements using the delete at method to specify the index of that element, and that element will be gone, and the array will shrink. The delete method allows you to delete more than one element. What you do is specify the value of the element to be deleted, and all those elements will be deleted from the array. So the array will shrink a lot more. Okay, so you specify a specific value. Now we have an array. Of course, 1 and 2 are fixed numbers, and AB is a string. There's no problem. Of course, the elements could be arrays themselves. Now you can create multi-dimensional arrays. You can arrays in arrays also. You have the standard methods, length, if you have 3. Arrays could be converted to S. So the to-S method is actually part of the class object. And any class would be subclasses of objects. So it inherits the to-S method. So array to string will give you a string. This concatenation of all the elements. You can reverse the array. Now again, this is non-destructive. If you put the bang at the end of it, then it will be destructive. This will append an element to the end. So A chain. If you delete, again, methods do not need parentheses, so you would see a lot of constructs like this. Normally you would put parentheses around it, but no, you don't have to do the typing. So this is the space, and that's the argument. So we're deleting any element in the array that looks like a 1. And then if you find out the value of A again, those 2 elements are gone. So now the array has been shrunk. This is a range. A range can be converted into an array by the to-A method. So you have AA, AB, AC, and you end up with an array of 3 elements. This shows you the delete at method. We are deleting the element at position 1 because that's the second one, AB. Now the value B is only AA and AC. Arrays could be sorted. If you don't have the bang, it's non-destructive. You can do array algebra. This is difference. So you have 1, 2, 2, 3, 3. You minus 3. Of course, 4 doesn't belong to the first array. So the 3's are taken out. Notice that the 2's are retained. So you allow duplicates when you're doing the difference. On the other hand, if you're doing intersection and union, you don't get the duplicates. So this is intersection. Intersection, you get, of course, 3, 3 intersect with 3, 3, you would expect 3, 3. Except that you don't get duplicates, so you only end up with a single 3. Same thing with union. 2 union 2, of course you get the 2, but you only get 1 on rather than 2. So now you get 1, 2, 3, 4. Plus sign. The plus sign stands for, can anybody guess? You have difference, intersection, union, division, combine. Yeah, concatenation. So you're concatenating, of course you don't lose any element, you just get more. Okay, so you can concatenate arrays. So this is very dynamic. Arrays can grow and shrink as you like. Hashes, you have a hash has keys and values, and the keys and values can be any object. Again, it's purely object oriented, so you're just using an object for a key, you're using an object for a value. You can use this method to create a neo hash, or you can use a hash literal. If you're using the interactive interpreter and you run out of space at the end of the line, what you do is just do the backslash, and now you get a continuation of the same line. Basically, because you basically have 1 statement per line. Okay? So this creates a hash, because just like in Perl, you use curly brackets. Unlike in Perl, you don't need a special character for a prefix to indicate hashes or arrays. The special characters do not denote the type, rather denotes the scope. So this is a hash with the name giving about John, and the name called major giving the CS. Hashes, of course, again, are dynamic, just like the arrays. You can always add more. Now, of course, to obtain the value, you provide the key, you get the value. You can always add elements to the hash. So we add a new element, year equals to 3, and now you get the hash has been expanded, and now you have 3 pairs. Iterators are very useful. If you have a collection and you want to go through a collection, you need an iterator. Iterators are built in the built-in classes. If you create your own class, you may want to define your own iterator value. Okay? The iterator usually says each or each something. The built-in iterators, you have built-in iterator methods for strings, ranges, arrays, hashes. This is a string. You can iterate over individual characters. You can iterate over individual bytes. This iterates over individual characters. Now we have a do block. Again, we have the parameter. Since the iterator will iterate through it, and will take on the string values 1, 2, 3. Of course, n is a string, so we need, if you want to add a number to it, we need to convert to an integer. So what we get is, we'll add 1 to a 1, 2 and 3. We get 2, 3, and 4. The value, of course, is still, the value of this block is still the string 1, 2, 3. A range, of course, also has its own iterator. That iterator, of course, is each. So we are iterating through the range, and we just print out. Okay, we get A, we get B, we get C. Arrays also has its own iterator. So A dot each. You have a do block. Now, of course, if you have a single line, using the curly brackets is easy. The do and allows you to have multiple lines. Of course, you can also use it for a single line. So the array, you iterate through Tom and Jerry, and we just print out the string. When you print out a string, you get to a new line. If you use the print method, it prints on the same line. Okay? So you get the Tom and Jerry. This is another way to create a hash. Looks like an array, but this has a hash. What is a hash? So the keys are now A and C, and the values are B and D. Okay. A hash has several iterators. Each will give you a key value pair. Okay. So this will give you pairs of keys and values. The do parameter, this could be on this line or it could be on the next line, doesn't matter. You'll get a key and goes to the K variable. The value will go to the D variable. Here we just print them out. So we have key, which is A, value is B, key is C, value is D. So this is the hash. You can also iterate through keys. So you use the each key method. Then what you get will only be the keys. So the keys will be assigned to the parameter K. We just print it out. The keys are, of course, oops, sorry. Wait a minute. I think this is that's my mistake. It should be A and C. If we use value here, then it will be method declarations. Of course, we want to be able to define methods. You just say def, and you have a block, and you have an end. You use method name followed by one or more arguments. Again, parentheses are optional. And then in between, of course, you have your Ruby code. You don't need a return statement because the value return will always be the last expression evaluated. We are not using parentheses. So f is the function name, x is the parameter. So we're defining a function called f with one argument. It will print out the string x, and then we'll do x plus x. Now, you get polymorphism here. Because we pass a string to the function, this becomes concatenation. But if we pass a number, then this becomes addition. So that's pretty dynamic. So we call f with the argument ABC, prints out ABC. But the value return, of course, is this, because this is the last expression executed. So we end up with ABC, ABC. On the other hand, if we have numbers, there's a space here. What other space is totally different? Okay. 2 is being passed, the output 2, and then 2 plus 2 gives you 4. Code blocks. Almost any value in Ruby would be objects, except a block. A block is not an object. However, you can turn a block into an object also. Okay? Now, a method cannot be passed as argument to another method. You cannot pass methods that way. However, you can pass a block to a method and have that block executed within the method. Okay? And the way to do that is to put a yield statement inside the method that you pass the block to. When the yield statement is encountered, then it will execute the block that's being passed to the method. You can also use arguments, because the block could start with parameters. Okay? To create an object out of a block, you can use the lambda function or prop. This will give you a prop object. Once you have a prop object, then you can do a call method, and that block will be executed. Okay. We are defining a method. We don't use hyphens in names. We can't. We have to use underscores. Underscores are kind of like a space. Okay. So we have a method here. This method doesn't do much. It just has a yield. Of course, you could have other statements in there for doing other computation. But basically, this will execute the block that is going to be passed to this method. Okay? And the arguments to be used in the block will be 2 and 4. Those are numbers. Okay? So this defines the method. To call the method, we have the block. Now, the block cannot stand alone. It has to follow a method. Otherwise, you can't just have a block by all by itself. Okay? So this is a method call. And this is the block that's being used. You can use the do-end block, or you can use curly bracket if it's only one line. We have 2 parameters that would take the arguments. Okay? We just print A plus B. Of course, A plus B means 2 plus 4 gives you 6. So when you pass this block to this method, we end up with a 6. Here we have a different block. Instead of doing addition, we do multiplication. But of course, the argument is basically fixed here. Of course, if you use a variable, then you have something more interesting. Those are constants. We are doing multiplication, so 2 times 4 would be 8. To create an object out of a block, here we're using the lambda function. Okay. So this creates an object called P. P is a prop object. Once you created the prop object, you can use the method call. And the block will be executed. Of course, the block could have arguments. So you pass this argument there, and we just print out. So this passing blocks to methods, you don't see another language much. Class definition, because in an object-oriented language, you need to define classes. The top level class is just the class called object. All other classes are subclasses of that. Class names are capitalized. Variable names are not. Method names are not. So method names and variable names are lowercase. Class names is considered a constant. Constant names start with capital N. If you want to subclass a particular class, then you use such. Otherwise, you'll be subclassing the object class. Instance variables. Instance variables are prefixed with the X symbol. So the prefix denotes scope, unlike in prop. Then you define the methods. Instance variables are always private, so you have pretty good encapsulation. So you cannot look at an instance variable. So you need to use the get and set methods. Class constants are always public. Methods could be private, protected, which means visible only in subclasses, or public. Classes are open. What does that mean? An open class means that the class can always be modified. Even the basic classes that are given, you can always modify, adding new methods, etc. So we have another example here. We have a class called student. When an object is created, Ruby will try to execute the initialize method. So if we want to initialize class variables, you would define this method. It takes one argument. This, since it starts with an at symbol, is an instance variable. So we are assigning the argument to the instance variable name. That defines that method. Now, this is also a method. What does it do?
Returns a name.
Right. It's a getter method. Okay. It's very simple. This is the last expression evaluated, so that's the return value. Now we create a student. The name is John. Now, this is a file, so we're not executing this until here. Okay. And then we put out the name of the student. Okay. So we run the file, and of course, once we created this object, we print out the name. This, in other languages, looks like a field in the class, but actually, in Ruby, it's a method. In Java, of course, methods always have parentheses. In Ruby, you don't see them. This is another example. Instead of using the initialize method, we'll use the get and set methods. Okay? So again, we have an instance variable called name. This is a get method, and this is a set method. A method name can be followed by an equal sign. Makes it look kind of like an assignment. Okay? So this whole thing is the name of the method. So we are assigning the argument to the instance variable. Okay? Now we just create a new student, and we set the name, and we put the name. Okay? Note notice that when we set the name, this looks like an assignment statement. Now, when you write it, you can put the space in front of the equal sign, it will still work. So it doesn't have to be, no spaces. Ruby would know. You would just, okay, quickly. One more. The instance variables are considered to be attributes in the class. So to make it simple for you to access the instance variables, you have attribute readers, attribute writers, and attribute accessors. The accessor, of course, can read and write. Okay? So those are anything that has a colon in front is an identifier. Okay. We still have the initialize method, and now you don't see the getter method or setter methods. Those are already incorporated in there. So they are defined implicitly. So we do exactly the same. This is calling the getter methods because the name has a getter method here. The major has both the getter method and the setter method. So this sets, well, initially is CS, then we set it, change it to math. We put up, and you see the name, major, and then a different major. Just to indicate that the class is open. I have an empty class. I create an object from that class. Now I can add a method. So I open up the class again and add a method. And this guy can use that method anytime. So when you say speak, modules, it allows you to collect methods and constants together inside of a class setting. You group them. However, modules cannot be instantiated unlike a class. In Ruby, you have single inheritance, that's like in Java. Of course, in Java, you have other ways of inheriting from other things. Okay? Same thing here. What you do is you have defined a class that inherits from a superclass, and then you add modules. That class will inherit the methods in the modules. Shall I? I have a module that defines the method. Okay, this is a module. I have a class that subclasses the array. I include the module so it can inherit this method. I create an array out of my class, and I can use the sum method because now it's mixed in. So it's now almost like multi-inheritance. Exceptions, of course, you have your throw, try, catch, things like that. Here you have the same thing except that the wording is different. Begin is like try, rescue is like catch, raise is like throw. Files, you can open files to read, write. Rails was developed by David Hansen in 2005. It uses a model view controller. This is very similar to the framework of .NET and the Java EE. That allows you to have, that allows the programmer not to worry about the minor details. That's all taken off by the framework. Okay. Of course, since it's open source, so it always uses open source modules. It includes a web server, it includes a database, which of course is open source database. There's no adapter to Oracle or SQL Server, so everything has to be open source. And there's some resources you can download, you can get all the information about Ruby from this. This gives you the documentation, and this gives you the Rails. The Rails, of course, again, it's a different lecture. Any questions?
No, we don't have enough time, unfortunately.